Hey everyone, Linus here, and today we're diving deep into the fascinating world of the Windows boot process. Now I know what you're thinking, boot process? Sounds boring. But trust me, understanding this seemingly mundane sequence of events is crucial. Not just for tech enthusiasts, but for anyone who uses a Windows computer. It's like understanding how the engine of your car works. You don't need to be a mechanic, but knowing the basics can help you diagnose problems and keep things running smoothly. Think about it. Every time you hit that power button, a complex chain reaction occurs behind the scenes. Your seemingly lifeless box of electronics springs to life, executing a precise choreography of hardware initialization, data loading, and software execution, all culminating in the familiar Windows desktop. This intricate dance, my friends, is the Windows boot process. Now, you might be wondering why you should even care about this hidden world. Well, imagine this. Your computer throws a tantrum and refuses to boot, greeting you with a dreaded blue screen of death. Panic sets in. But wait, armed with the knowledge of the boot process, you can calmly analyze the error messages, pinpoint the culprit, and potentially even fix the issue yourself, saving you time, money, and a whole lot of frustration. In this guide, we'll break down the entire boot process into bite-sized chunks, making it easy for you to grasp. We'll explore the roles of key players like BIOS, UEFI, the boot manager, and the kernel, and we'll even equip you with the tools and knowledge to troubleshoot common boot problems. So buckle up, grab your favorite beverage, and let's demystify the Windows startup. Alright, let's kick things off with the very first step in the boot process, the BIOS or UEFI. Think of this as the computer's wake-up call. It's a small program stored on a chip on your motherboard, and its job is to initialize your hardware and get everything ready for the operating system to take over. Now you might hear both BIOS and UEFI being thrown around. BIOS, which stands for Basic Input-Output System, is the older of the two. It's like that old, reliable but slightly clunky car you learned to drive on. UEFI, or Unified Extensible Firmware Interface, is its modern, sleeker counterpart with more features and flexibility. It's like upgrading to a Tesla. Regardless of whether your system uses BIOS or UEFI, the next step is the POST, or Power On Self-Test. As the name suggests, this is where your computer does a quick health check, making sure all the essential components are present and functioning correctly. It's like your computer doing a quick stretch and making sure all its limbs are working before it starts its day. The POST checks things like your RAM, CPU, hard drive, and keyboard. If everything checks out, you'll usually hear a single beep signaling that it's all systems go. However, if the POST encounters any issues, it will let you know by emitting a series of beeps, each beep code corresponding to a specific hardware problem. This is where those cryptic beep codes come in handy, acting like your computer's way of saying, "Hey, something's wrong, help me." Once the POST is complete, the BIOS or UEFI knows that the hardware is good to go, and it's time to move on to the next stage, finding the operating system to boot from. And that, my friends, is where the boot manager comes in. So the BIOS UEFI has done its job, the hardware's all fired up and ready to go. Now the million-dollar question, where's the operating system hiding? This is where the boot manager struts onto the stage. It's like the stage manager of a grand theatrical production, responsible for finding the right actor, in this case the operating system, and giving it the spotlight. The boot manager's primary job is to locate and execute the operating system's bootloader. To do this, it relies on a crucial piece of information stored in a file called the Boot Configuration Data, BCD. Think of the BCD as a master playbook that tells the boot manager where to find all the bootable operating systems installed on your computer. Now you might be wondering, what if I have multiple operating systems installed? No problem, the boot manager's got you covered. It'll present you with a boot menu, allowing you to choose which operating system you want to boot into. This is particularly handy if you're a dual booting aficionado, rocking both Windows and Linux on your machine. Once the boot manager has successfully located the bootloader of your chosen operating system, it passes the baton, giving the bootloader control of the boot process. From here on out, it's the operating system's show to run. Section 4. Loading the core, the Windows bootloader and kernel initialization. With the baton passed, the Windows bootloader, a small but mighty program typically residing in the boot partition of your hard drive, takes center stage. Its mission? To load the heart and soul of the Windows operating system, the kernel. Think of the kernel as the brain of the operating system. It's responsible for managing the system's resources, talking to the hardware, and providing essential services for all the other software that runs on top of it. The bootloader carefully loads the kernel into memory, a critical step in bringing your computer to life. But it doesn't stop there. It also loads essential device drivers, which act as translators between the operating system and your hardware. Without drivers, your operating system would be like a tourist lost in a foreign country, unable to communicate with the locals. Once the kernel is loaded and the essential drivers are in place, the bootloader steps aside, its job done. The kernel, now in control, starts flexing its muscles, setting up the system, and preparing for the arrival of user space applications, the programs you interact with daily. Section 5. User Space and Beyond. Session Manager, SMSS, and User Login. With the kernel settled in and the system prepped, the Windows boot process enters its final act, launching the user environment. This is where Session Manager, SMSS, a critical system process, takes the reins. Imagine SMSS as the director of a grand play. It sets the stage for your user session, loading the user interface, initializing network connections, and preparing the system for your commands. One of SMSS's key tasks is to launch the Windows Logon screen, that familiar gateway to your personalized desktop. This is where you enter your credentials, authenticating yourself and gaining access to your files, applications, and settings. Once you've logged in, SMSS takes a back seat, but its role is far from over. It continues to run in the background, managing your user session, handling log-off and shutdown procedures, and ensuring the smooth operation of your Windows experience. And there you have it.